So for this question over here, we're told that the total resistance is 10 ohms, and we need to find out what the unknown resistance R1 is. So R1 is over here, and we know that the total resistance of this whole circuit, when you do the equivalent circuit, is going to be 10 ohms. So in other words, the resistance from point A to point B is going to be 10 ohms in total. Alright, so when we're doing this, we generally want to start from point A, and the idea here is to combine all of these together, all of these resistors, and get them to become one equivalent resistor. So we have something that looks like this, right? And then we'll be able to find out what that resistance is, and that's, actually no, sorry, that would be RT, and that's equal to 10 ohms. But we know that the RT formula is equal to something like, it might be like R1 plus R2 plus R3, or it might be something like RT is equal to, R1 parallel with R2. We're going to figure out which formula we're going to use in a second, but it's a pretty straightforward question. So what we're going to do is we're going to combine the resistors together. So the first thing we'll do is we'll start from point A over here, and we're going to look into the circuit here to figure out which path the electricity will take. So let's say, for example, the electricity is coming in and it's at 10 volts, like this. As it comes in from A, that 10 volts is going to come to this node over here, and it's going to go through this resistor maybe, but let's go around this way as well, because electricity likes to follow the path of least resistance. So before we go through this 24 ohm resistor, let's follow the path of least resistance to see where it takes us. So we're going to follow, and we're going to say that the electricity continues to have 10 volts of charge because there's no resistor in our path that decreases the voltage. Okay. Alright, so at this point, the electricity has gone around this way, and it could go back over this 24 ohm resistor, but it won't, because if it did, then it would be clashing with this current that's coming through like this, right? Electricity goes in one direction. So it's not going to go back through this 24 ohm resistor. It's actually going to go down like this. Okay. So it seems like there's really two ways to get to this point over here. One way would have been to go through this 24 ohm resistor, and the other way was to go around like that. And since we can get to this point over here without going through this resistor, we know that the electricity is not going to go through this resistor at all, because it has two different ways that it can go, and it's going to follow the path of least resistance. Then you might be wondering, well, what if there is a small resistor here? Let's draw that in. What if there's a small resistor here? Let's say it's like 12 ohms. Would it only go through a 12 ohm resistor? Would it leave the 24 ohm resistor alone? No. In that case, it's going to go through, the electricity is going to move through the 12 ohm resistor and the 24 ohm resistor, but more is going to go through the 12 ohm resistor than the 24 ohm resistor. And that's kind of a topic for a different video, but for now, we know that if there's no resistance at all, then the electricity is going to go through the path of no resistance. And that's just called a short circuit. So there's going to be this 24 ohm resistor is short circuited. So it's not being used by the electricity at all. Okay, so the electricity gets to this 24 ohm resistor, and if it wants to get to B, right, then it needs to go through this resistor, which happens to be in the back. So it's gonna go through like this, and then it's gonna spread in two different directions. So let's say it goes this way, and then it goes this way, well, it hits a resistor, so that could happen. The other option is to just go through this wire here and then go through like this to B. Okay, so that's one path that could happen. Another path is you could have the electricity go straight out of A like this, and it goes through R1, and then the voltage drops, so it turns green, and it goes to point B. And another path is it could have gone through this 120 ohm resistor right here, and then it would have had a voltage drop like this, and this electricity will not go through this resistor here because there's another path here that has zero resistance to get to B. So this 24 ohm resistor is also short-circuited. So if you look at the path of the electricity, it kind of goes like this. It starts off at A, and then it goes through a 24 ohm resistor. So it can go through a 24 ohm resistor, this one over here, or it could go through R1, or it could go through 120 ohms. So 120 ohms. Okay, if it goes through the 24 ohm resistor, then it's going to go down and then straight to B. So that's going to connect straight to B. If it goes through R1, then it's going to go down and connect straight to B. So R1, that to B. And if it goes through the 120 ohm resistor, well, it's going to just go and connect straight to B, like that. So that's kind of the flow of the electricity simplified. Okay, so this is pretty easy. We've got 3 resistors here that are in parallel, and we know that the total resistance here is going to be 10 ohms, because that's what the question tells us. So we know that RT is equal to R1 multiplied by R2 multiplied by R3 divided by R1 plus R2 plus R3. This is just the general formula for parallel resistances. Generally use this equation, R1 times R2, and then R1 plus R2. But you can keep on expanding it if you have like multiple pathways. So let's go ahead and get rid of this. And what we're going to do is RT, we know that's 10 ohms. R1, we know, well, we don't know what that is, so we'll keep that there. R2, we can just say that's 120 ohms. And then R3, we can say that's 24 ohms. It doesn't really matter if you set R2 to 120 or 24. Then down here, we'll have R1 plus 120 plus 24 ohms. And now we just have to solve this formula, which may be easier said than done, but let's try anyways. So 20 ohms is equal to R1, and then that's going to be multiplied by 120 times 24. So I don't know what that is off the top of my head. I'll probably have to grab my calculator. Let's see. So 120 times 24, that's 2,880. 2,880. And at the bottom, we're going to have R1 plus 120 plus 24. That's going to be 144. And I wonder if we can simplify this a little bit. So what we could do is, I think we could probably divide the top and the bottom by 12. Yeah, we can. Oh, but we can't do that here because we're adding R1. So sorry, that's a bit of a math thing there. So yeah, we'll keep it as is, and we'll keep on doing the math to figure out what R1 is. So when you're in this kind of situation, what you want to do is multiply the 10 ohms by R1 and then the 144. So you've got rid of this bottom part here, and that's going to be equal to R1 times 2880 divided by R1 plus 144, and you also multiply this by R1 plus 144. This cancels this out, and so let's make some more space for ourselves. We'll delete this, and we'll move this up like that. Okay, so now we've got 10 times R1 plus 144 is equal to R1 times 2880. Okay, then we can expand these, so we'll get 10 R1 plus 1440 is equal to R1 plus 2880. We can move the R1 to the other side, so now we'll have 9 R1, and we can move the 1440 to the other side, and we'll have 2880 minus 1440, that's just equal to 1440. And then we just divide both sides by 9. So that'll be, let's see, just pulling out my calculator again. 1440 divided by 9, that's 160. And that's all there is to it. So that's going to be 160 ohms, and that should be the answer. Okay, hopefully that was helpful. If you found this video helpful and you'd like to have private tutoring, just let me know. You can send me a private message, and we can set up a initial meeting just to see if we're a good fit together. Okay, bye.